I'm just going to put out a little video here for you and kind of let you know that I'm thinking about you and what it is that I can do to help you still be successful and kind of distract you from the news of the day and everything that's going on. If you have had the opportunity to, keep checking in on Google Classroom and check your Gmail and PowerSchool just for any updates or announcements. And if you have any questions, please feel free to reach out and ask in however that can be done. And I'll do my best to get back to you or at least pass your information along to people that know a little more clearly. I wanted to take today to cut together a little video for you about one of the assignments that I'm working on that I think you might see if you're working on Khan Academy. Keep doing that. Keep up with the stuff that you're doing. What I wanted to share with you is a way to immerse yourself into a task that you need to do and do it totally from a digital standpoint. The assignment is out of the applications of integration, areas between curves that intersect at more than 2 points, and it's calculator active. You have to use a calculator for this question. So I'll pause my own talking while you maybe get that set up, pause the video. But I recommend having not only that assignment up on Khan Academy, but also have Desmos. And you can see that I have Wolfram Alpha up and running. I'm going to share with you something that's going to help make maybe some of these solutions a little more complete. So go ahead and get that up. Desmos, Khan Academy, and Wolfram Alpha. Okay, assuming that you pause and you're back. The assignment that I have, I've worked through 3 of these, and I just kept getting closer and closer to a way to kind of cheat the system using Desmos and some of the power of Desmos. You can do this with the TI-84s or TI Inspires, but it's a little more cumbersome. I'd recommend just integrating paper and pencil calculations, but I'm going to do this entirely from Desmos and Wolfram Alpha. The question that I have over here, maybe a little highlight, let f of x equal 18 log base 10 of x, and g of x equal 0.5x cubed minus 8x squared plus 34.5x minus 27. I don't want to deal with any of that writing it down, and I want to never have to write those functions more than once. So side-by-side split screen, I'm going to go over here into Desmos. Again, sorry for the capturing the computer keyboard clicks. I'm going to make buying a microphone a priority just for my future. You can do log base by doing shift, like underscore. This symbol, you can kind of see it right there. So that's shift underscore gives me the base 10 option. And then that's my first function. That's what f of x looks like. Over here it's a blue. I'm going to change the colors in a second just to make it help match what Khan Academy is showing. The g of x function is 0.5x to the third minus 8x squared plus 34.5x minus 27. And so we kind of see how they match. They have the shaded region R and the shaded region S. The goal of this question and this entire task out of applications of integration, area between curves, I mean, you can just copy paste this or type this into Google and it'll pop up automatically. Make sure you're signed in on Khan Academy so you're getting your credit and your points, and they're still capturing whether that means anything or whatnot, but grade-wise, whatever, but just that we're logging your work. We're going to find the sum of the areas of the regions. So when we have 2 curves, we want to talk about how much space is between them. The reason why this question is also you can't go from start to finish is the fact that they cross, and there's a section R where G function is above it, and then after that point where they intersect, G function is below. It's the bottom function. So we have to do some sort of subtraction problem. I've also set it up because I had 4 of these. You'll have 4 of these. That I'm going to say A equals 1 because that's the first x coordinate where they cross. And B equals 10. That's the second x coordinate where they cross. And so there's this region from A to B. And my screen just went black to capture it. I said I was going to match the color. So to match the color, click on Edit, and then that's the little gear. And then I can change the F function to be blue and the G function to be sort of red, sort of maroony colored. Okay, so this function right here, this is the entire interval. This is from 1 to 10, and maybe I actually don't want that up there, but I just thought I'd show it where it's happening. We're talking about what Khan Academy is showing, how it's R to S, is this same region, but this is just graphed on a square plane. Okay, so if I do the integral from A to B, and I'm subtracting one from the other, one function like the f function, f of x minus g of x dx. I do get a value. That's not the answer, but it's a good setup or a structure to the problem. The thing with this type of a question is it's asking us for this place where the two lines cross, and Desmos is, I mean, I searched around kind of like for like 30 seconds. I didn't really give it a deeper analysis, but it only provides us with up to 3 decimals. And if our answer is asking for 3 decimals, then you're doing a calculation where you've rounded in the middle. That might be okay. We might get away with it the majority of the time, but in those situations where we don't, and we have to be more precise, we're looking for this x coordinate in a little more precision than 4.506. So that's where I use Wolfram Alpha. And so Wolfram Alpha allows us to find a solution for x on a much finer detail, especially because the f of x function is a logarithmic function, and then g of x is a polynomial function. There's no nice solution between those. We can only approximate solutions. So that's exactly what I'm going to do. And I don't want to actually have to calculate it by hand. I'm going to let Wolfram Alpha use Newton's method to approximate, I'm just going to say Newton's method for 18 log base 10 of x minus, and I have to use subtraction because we're subtracting the two different functions. I should show that over here. Sorry. F of x minus g of x. It's going to create a root 4.506. Again, only correct to 3 decimals, and I'm probably going to need more than 3 decimals, and so Desmos isn't showing it. But this 4.506, where f and g cross, is the same solution as if I subtract f of x minus g of x, and it's going to be on the x-axis. I don't really need that. I just wanted to make that go away. But I'm trying to get more accurate. The key thing here is I'm going to get more accurate for a further step, and so I need 4.506 to be a more accurate value. So I'm going to go Newton's method, and I'm going to subtract the f function and the g function. Notice I'm putting the g function in parentheses, minus 8x. Feel free at any time to like skip forward and scrub the video. Near 4.5. Remember, you have to, there's probably multiple places where the functions are crossing. So I want to be more accurate. So this entire code, check it out. Like I can just kind of verify 18 log base 10 of x minus the whole polynomial. We want it equal to 0. Maybe I don't need to, but I just chose equal to 0 because Newton's method identifies roots, and roots happen when your functions equal 0. Newton's method, machine precision, which means crazy precise, and then around 4.5. And so it gives me 4.50616. I think 5 decimals should be enough. 4.50616. That's going to become my k value, 4.50616. I could go even more decimals because it's there, so I might as well. 492819. 492819. Okay, that's crazy precise. That's like nearly 10 decimals in precision. Engineers don't even have to be that precise, but it's there just for the fact that having 3 decimals, Desmos gave us 3 decimals. That's probably okay, but in case it's not, and we're off by that just enough amount that we don't get the credit over here, I want to be right. I will be honest and transparent. I haven't done this problem yet to check if I'm going to get the right answer, but I've done 3 other ones right, so there it is. Okay, backtracking. First of all, type the entire function. Type the second function and look at them, visualize them over here on the screen. Oh, my mouse got big. Do it again. There, did it again. Okay. I'm going to get rid of the a is less than or equal to x is less than or equal to b, that interval. I don't need to see that right now, although it's trying to capture the space between these two curves. I chose a equals 1 and b equals 10 so that if I get a different problem, I can just take this first x coordinate and make that equal a, and this second x coordinate make it equal b, and then I don't have to do a lot of retyping. I can change a little bit of things. But here's where I'm going to get a lot of trick right now. After the functions are entered, the boundaries are entered, maybe you do or do not want to put the interval. Now we're ready to do the math that'll get us the digital calculation for the answer. We're talking the integral from a to k. That's because we're going from the first place where the graphs cross to this k value, 4.506. The top function is g of x. So in this interval, I want to go g of x minus f of x dx. And that means that the area of region R is 22.812, blah, 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 blah. Well, I can even go the integral from k to b. Now this time f is on top. F is the blue function. F is the blue function. So I can go parentheses f of x minus g of x dx. And I can get these two values, and I can add these two values and have the answer. But why not just put them together? Oh, look. Now I have, without actually typing out all of the little functions like 18 log base 10 of x equal blah, blah, doing all that, I can just let the fact that this computer software remembers that those functions all line up, that g is defined ahead of it. So I can try to make the code visible. Again, feel free to fast forward at any time. Here's the entire code. For my problem, you just change it for yours, change it for yours, change it for yours, change it, change it, change it. The Newton's method is the challenging part, so copy this and understand where this came from. Newton's method for the first function, the second function, you're subtracting them. But the answer is 104.644. Okay, if I'm wrong, I'll fix it in the video and show you what I needed to think about as I solved it. If not, I'm probably almost done. 104.644, 3 decimals. That answer, adding the areas together, check it. It's a good sound. Okay, so before I move forward, just go ahead and remember that if you are stuck, go ahead and message me on Google Classroom. I know we got spring break coming up, and so, or to date the video, if you have any breaks that you have to take them. But if you are wanting to get some work done, I'll be posting some book work, or I'll be posting other things, and certainly just keep working on your Khan Academy. I'm really just kind of like as a curiosity, seeing how far you guys can get before you say, we're done. Best of luck. Let me know and upload the video. How do I finish this one? Please like and subscribe, click the bell, and thank you to my Patreon for, just kidding. All right, bye.